Welcome students. In this question we are going to be checking whether a certain number is prime or not. Now this certain number has 44 digits and it is created using 11 numbers formed or picked between or from 1995 to 1985. Now let me write down these numbers. So starting from 1995 we got 1994, 1993, 1992, 1991, 1990, 1989, 1988, 1987, 1986 and 1985. Okay, now the conclusion whether this number formed is prime or not has already been done by another author, and what I found in the video is a conclusion which has got no rigorous proof involving. So the point I wish to mention here is that in mathematics we cannot pick cases and boil down a conclusion without a rigorous proof being there to substantiate our judgment. So that is the reason I thought I can do this video. So now before I could do the core part, let me just tell you what the author did in the previous video. The author takes up digits which are found at odd points, and the method he adopts is the following. He says that sum up all these numbers which you find here at these points. So if you are going to take the number at 1, you pick up the number at 1 and add up the number that occurs in position number 3, and then follow it up by adding the number that occurs at position number 5, and then you go on and so forth. So if you were to do this, this would produce you a value of 105. So in other words, what the author wants you to do is to sum up all digits which are occurring at odd points. Let me write that down. All digits that occur at odd points. Now this would add up to 105. Then you sum up the digits that are left. So this is going to be 9 added with 5, and then with 9, and then 4, and so on and so forth. So that would give you around 149, and then he subtracts 149 minus 105. You are going to get 4 and 4 and 0. So this is what you're getting, and this is clearly divisible by 11. So this would mean the 44 digit number is not a prime number. So this is the conclusion he draws. Now the problem is there are countless methods like this for divisibility of numbers. Say for example, I can also give you another divisibility check for the number 11. So you got 1991. Now if you were to add 19 with 91, 9 plus 1, 10, carry 1, 10 and 11. So this is clearly divisible by 11. On the contrary, if you were to pick another number, say 1994, if you were to add these two numbers, 19 and 94, 9 and 13, 1, 10 and 11, this number is not divisible by 11. Okay, it's not divisible by 11. Now the problem with these techniques is that they are not hard and fast supported by a concrete proof, meaning we cannot base our conclusion specifically in problems like this because a number is given of this fashion. Of course the shortcut works in certain cases, but the problem is there a hard and fast justification by a systematic proof? And that is the reason I would want to present this proof before you. So the point is, I want to know if a given number is divisible by 11. Of course, the technique that the author has taken in the video is purely valid, but it would be valid if a justification by means of a proof is given. So that is the only issue. Let me start off with the proof. Let us consider, I'm going to start like this, let us consider a 4-digit number. And I'm going to take it as A, B, C, D. Now since this is a 4-digit number, I can rewrite this as A times 1000 added with B times 100 added with C times 10 added with D. Now I can rewrite this as A multiplied with 1001 minus 1, this is same as 1000, positive B, 99 plus 1, positive C, I can write C as 11 negative 1, positive D. I can do that because 99 plus 1 is going to be 100, 11 minus 1 is going to be 10. Now what I'm going to do is I'm going to rewrite this as A times 1001 plus B times 99 plus C times 11. Next I'm going to rewrite negative A, positive B, positive, it has to be negative, so negative C, positive D. So this is what I've got. Now clearly we can see that this is A of 1001, positive B of 99, positive C of 11 is divisible by 11. Okay, so there's nothing to prove there. Now for A, B, C, D to be divisible by 11, this quantity negative A, positive B, negative C, positive D should either be equal to 0 or it has to be equal to 11. So what is the meaning of this? So if I were to rewrite this, this can be rewritten as B positive D negative A positive C is equal to 0. So clearly this should be equal to 0 or it would be equal to 11. And now you know why exactly we are adding up the digits and subtracting it and checking it for the quantity 0 or 11. So I will give you an example. Say take for example 2431. Now if I were to add 2 with 3 and subtract the remaining 4 with 1, clearly I get 5 negative 5, so is equal to 0. So this is divisible by 11. Now say for example I am taking 2453. If I were to add 2 with 5 and add 4 with 3 and subtract, again we are getting 0. So again it's divisible by 11. In this problem, the 44-digit prime number is a mere extension of the proof that we have just seen here, because clearly you can see if you were to add up and subtract the digits, you will end up with 44 no matter how you are rearranging. The total will not get changed. You can try that out and see for yourself. So having mentioned that, I hope you understood the solution to this question. Students, have a nice day.